When addressing electrical safety concerns in a container handling port, especially where 480 volts lines run under the quay and electricians may come into contact with water, it is essential to refer to the National Electrical Code, or NEC, for guidance. Several articles within the NEC address these specific concerns. Article 555, specifically pertaining to marinas and boatyards, offers critical insights. Section 555.17 focuses on grounding requirements, ensuring that electrical systems are grounded in accordance with Article 250. This is vital for minimizing the risk of electrical shock. Section 555.18 emphasizes the importance of bonding, mandating that all electrical equipment and metal raceways are effectively bonded to the grounding system. This creates a low impedance path for fault currents, facilitating the operation of overcurrent protective devices. Section 555.20 discusses the proper installation of electrical equipment located above grade, providing guidance on how to protect such equipment from environmental factors. Article 590 is relevant when dealing with electrical systems in hazardous classified locations. Class 1, Division 2 locations are those where flammable gases, vapors, or liquids are handled, processed, or used. This article provides guidelines for ensuring electrical safety in such environments. Article 680 addresses swimming pools, fountains, and similar installations, offering additional safety measures that can be applied to environments where water is present. Section 680.20 specifically requires ground fault circuit interrupters, or GFCIs, for personnel protection in these areas. Addressing the specific concerns raised, firstly, proximity to water requires careful consideration. All electrical equipment and lines must be protected from water ingress and corrosion. Secondly, electricians should never work on live electrical equipment while in contact with water. Thirdly, a critical safety feature is the installation of easily accessible disconnect devices for control panels to isolate equipment in case of an emergency. To mitigate these risks, several modifications are recommended. Firstly, protect the 480 volts lines from water exposure by using waterproof conduit or trenching. This will help prevent water from coming into contact with the electrical conductors. Secondly, elevate control panels and other electrical equipment above the potential water level to further reduce the risk of water damage and electrical hazards. Thirdly, install GFCIs in all electrical circuits to protect personnel from ground faults. GFCIs are designed to quickly interrupt the circuit when a ground fault is detected, minimizing the risk of electrical shock. Fourthly, ensure that each control panel has a dedicated disconnect device such as a breaker or fuse to isolate the panel in case of an emergency. This device should be easily accessible to the electrician working on the equipment, allowing for a quick and safe disconnection of power. Several specific NEC sections support these recommendations. Section 555.17 paragraph B requires electrical systems in marinas and boatyards to be grounded in accordance with Article 250. Section 555.18 requires all electrical equipment and metal raceways in marinas and boatyards to be effectively bonded to the grounding system. Section 590.6 paragraph B number 1 requires all electrical equipment in Class 1. Division 2 locations to be approved for the specific hazardous conditions. Section 680.20 paragraph A requires all circuits supplying electrical equipment in or near water to be protected by a GFCI. In the context of the electrician's safety, the installation of disconnect devices at each control panel is paramount. This ensures that in the event of an accidental contact or any other emergency, the electrician can quickly de-energize the equipment they are working on. The disconnect device should be readily accessible and clearly labeled for easy identification. Moreover, regular inspections and maintenance of the corrosion protection system are crucial. This includes checking the integrity of the waterproof conduit or trenching, inspecting the condition of the grounding and bonding connections, and testing the functionality of the GFCIs. Any signs of corrosion, water damage, or other issues should be addressed promptly to maintain the safety and reliability of the electrical system. Furthermore, consider implementing a lockout-tagout procedure for all electrical work. This procedure requires that the disconnect device be locked in the off position and tagged with a warning label to prevent accidental re-energization of the circuit while work is being performed. Training electricians on the proper use of lockout-tagout procedures is essential to ensure their safety. Another important aspect is the selection of appropriate electrical equipment for the marine environment. Equipment should be rated for wet locations and resistant to corrosion from salt water. This includes using corrosion-resistant enclosures, fittings, and wiring. The use of stainless steel or other corrosion-resistant materials is highly recommended. In addition to the NEC requirements, consider consulting other relevant standards and guidelines such as those published by the Institute of Electrical and Electronics Engineers, or IEE, or the National Fire Protection Association, or NFPA. These organizations offer valuable information on electrical safety in marine environments. Furthermore, a comprehensive risk assessment should be conducted to identify potential hazards and implement appropriate safety measures. This assessment should consider factors such as the proximity to water, the presence of flammable materials, and the potential for electrical shock. The results of the risk assessment should be used to develop a detailed safety plan that outlines the procedures and precautions to be followed when working on the electrical system. It is also important to ensure that all electricians working on the system are properly trained and qualified. This includes training on the NEC requirements, safe work practices, and the proper use of personal protective equipment, or PPE. Regular refresher training should be provided to keep electricians up to date on the latest safety procedures. Furthermore, consider the use of arc flash protection. Arc flash is a dangerous electrical hazard that can occur when there is a short circuit or other electrical fault. Arc flash can cause severe burns, blindness, and even death. To protect electricians from arc flash hazards, it is important to conduct an arc flash hazard analysis and implement appropriate safety measures, such as the use of arc-rated PPE and the installation of arc flash barriers. The NEC provides guidance on arc flash protection in Article 110.16 and Article 130. In addition to the technical aspects, it is important to foster a strong safety culture within the organization. This includes promoting open communication, encouraging employees to report safety concerns, and recognizing and rewarding safe behavior. Regular safety meetings and training sessions can help to reinforce the importance of safety and keep employees informed of the latest safety procedures. Furthermore, consider implementing a safety management system, such as the Occupational Safety and Health Administration, or OSHA, Voluntary Protection Program, or VPP. This program recognizes companies that have implemented effective safety management systems and have achieved injury and illness rates below the national average. Implementing a comprehensive safety program that addresses all of these aspects will help to ensure the safety of electricians and other workers in the container handling port. The combination of NEC compliance, proper equipment selection, risk assessment, training, and a strong safety culture will create a safe and reliable electrical system. Moreover, it is crucial to establish a clear line of communication between the contractor who installed the corrosion protection system and the port's electrical maintenance team. This ensures that any modifications or repairs to the system are carried out in accordance with the original design and safety standards. Regular meetings and consultations between the contractor and the maintenance team can help to identify and address any potential issues before they become major problems. Furthermore, the port should maintain detailed records of all electrical work performed, including inspections, maintenance, repairs, and modifications. These records should be readily available for review and should be updated regularly to reflect the current status of the electrical system. Accurate and up-to-date records are essential for effective maintenance and troubleshooting. In addition to the specific recommendations outlined above, it is important to consider the overall design of the electrical system. The system should be designed to minimize the risk of electrical hazards and to provide a safe and reliable power supply. This includes using appropriate wiring methods, providing adequate overcurrent protection, and ensuring that all equipment is properly grounded and bonded. The design should also take into account the environmental conditions, such as the presence of salt water and the potential for flooding. Furthermore, the port should have a written emergency response plan that outlines the procedures to be followed in the event of an electrical accident or other emergency. This plan should include procedures for shutting off power, providing first aid, and contacting emergency services. All employees should be familiar with the emergency response plan and should be trained on how to respond in an emergency situation. In summary, addressing electrical safety concerns in a container handling port requires a comprehensive approach that encompasses NEC compliance, proper equipment selection, risk assessment, training, a strong safety culture, and effective communication. By implementing these measures, the port can create a safe and reliable electrical system that protects electricians and other workers from electrical hazards. The information provided here is intended to provide guidance on electrical safety in container handling ports and should not be considered a substitute for professional engineering advice. It is important to consult with a qualified electrical engineer to ensure that all electrical work is performed in accordance with applicable codes and standards. Electrical safety is a critical concern in any industrial environment, and it is essential to take all necessary precautions to protect workers from electrical hazards. By following the recommendations outlined above, the port can create a safer working environment for electricians and other employees. In addition to the aforementioned points, consider the implementation of remote monitoring systems for critical electrical parameters. These systems can provide real-time data on voltage, current, and temperature, allowing for early detection of potential problems. For example, a sudden increase in current could indicate a ground fault or other electrical fault, allowing for prompt intervention to prevent a more serious incident. Remote monitoring systems can also be used to track the performance of GXEIs, ensuring that they are functioning properly and providing the intended level of protection. The data collected by these systems can be used to identify trends and patterns, allowing for proactive maintenance and troubleshooting. The use of thermal imaging cameras can also be a valuable tool for identifying potential electrical problems. Thermal imaging cameras can detect hotspots in electrical equipment, which can indicate loose connections, overloaded circuits, or other issues. Regular thermal imaging inspections can help to identify and address these problems before they lead to equipment failure or electrical hazards. Furthermore, consider the use of surge protection devices, or SPDs, to protect sensitive electronic equipment from voltage surges. Voltage surges can be caused by lightning strikes, power grid switching, or other events, and can damage or destroy electronic equipment. SPD are designed to divert surge currents away from sensitive equipment, protecting them from damage. The NEC provides guidance on the selection and installation of SPD in Article 280. It is also important to ensure that all electrical equipment is properly labeled. Labels should clearly identify the voltage, current, and other relevant information for each piece of equipment. Labels should also warn of potential electrical hazards such as shock and arc flash. Clear and accurate labeling is essential for ensuring that workers are aware of the potential risks and can take appropriate precautions. In addition to the technical aspects, it is important to consider the human factors involved in electrical safety. Workers should be trained on how to recognize and avoid electrical hazards, and they should be encouraged to report any safety concerns they may have. It is also important to provide workers with the necessary tools and equipment to perform their job safely, such as insulated tools, voltage testers, and personal protective equipment. Furthermore, consider the use of human-machine interfaces, or HMIs, to provide workers with real-time information on the status of the electrical system. HMI can display data on voltage, current, and temperature, as well as alarms and warnings. This information can help workers to make informed decisions and to avoid potential electrical hazards. It is also important to ensure that the electrical system is properly grounded and bonded. Grounding and bonding are essential for providing a low impedance path for fault currents, which helps to protect workers from electrical shock. The NEC provides detailed requirements for grounding and bonding in Article 250. In addition to the above, consider the implementation of an energy management system, or EMS. An EMS can help to optimize energy consumption and to reduce the risk of electrical hazards. An EMS can monitor energy usage, identify areas where energy is being wasted, and automatically adjust electrical loads to reduce energy consumption. An EMS can also provide alerts when electrical parameters exceed predefined limits, allowing for prompt intervention to prevent potential problems. Furthermore, consider the use of renewable energy sources, such as solar panels or wind turbines, to reduce the port's reliance on the electrical grid. Renewable energy sources can provide a clean and sustainable source of power, and they can also help to reduce the port's energy costs. However, it is important to ensure that renewable energy systems are properly integrated into the electrical system and that they meet all applicable safety standards. It is also important to consider the environmental impact of the electrical system. The use of energy-efficient equipment and the reduction of energy consumption can help to minimize the environmental impact of the port. It is also important to properly dispose of electrical waste, such as used batteries and lamps, to prevent pollution. Furthermore, consider the use of biodegradable or recyclable materials in the electrical system. In conclusion, ensuring electrical safety in a container handling port requires a multifaceted approach that encompasses technical, human, and environmental considerations. By implementing the recommendations outlined above, the port can create a safe, reliable, and sustainable electrical system that protects workers, minimizes environmental impact, and supports the port's operations. Remember that electrical safety is an ongoing process, and it is essential to continuously monitor and improve the electrical system to ensure that it meets the evolving needs of the port. Staying up to date on the latest electrical codes and standards, participating in industry training programs, and fostering a strong safety culture are all essential for maintaining a safe and reliable electrical system.